In this question, we have to find the current passing through the battery here I. So we have to find this current I in the circuit that is redrawn. Circuit is redrawn. After this, it is the balanced which was 5 upon 2.5 upon 2.5. So this condition Q is equal to R by S of Wheatstone bridge balance condition. Bridge balance condition is satisfied. So resistance of 6 ohm is removed. After removal, 5 and 3 in series, 2.5 and 1.5 in series, so it will become 5 plus 3, 8, and 2.5 and 1.5, 4. So E and E के अक्रॉस में रेजिस्टेंस हो जाएगा 8, 5, 3, 8 and 2.5 and 1, 4. So 8 and 4, they are in parallel. पैरेलल का फॉर्मूला हो जाएगा R1 R2 upon R1 plus R2, 8 on 4 upon 12. So this is 8 by 3 ohm. And total resistance of the circuit will be this 8 by 3 plus 1.5 plus 5.5 plus 1 by 3. Or we can write here technical LCM 3, 8, 1. 5.5 and 1.5, it will become 7. So 7 3 ja, it will become 30 upon 3 means 10 ohm resistance. So current will become voltage V divided by total resistance 1 by 2 and 0.5. So option here is 4. This question, electrical circuit voltage and current is there. Resistance we know V by I, and take the log and differentiate, will become delta R upon R plus minus delta V upon V minus delta upon I. If we put here delta R upon R, R की वैल्यू हो गई 10, delta V 4 divided by 200, 0.2 divided by 20. सॉल्व करते हैं, टेकिंग जैसे 200 हम ले लिया तो 4 एंड जाएगा 2 एंड डेल्टा R 10 उधर मल्टीप्लाई हो गया like this. So delta error in resistance 6 upon 20 or 3 by 10.3 ohm. Resistance can be written as 10 ohm and this error 0.3. Here option this question. Wire has resistance 81 ohm. Is the total resistance of another wire of B is same material and same length but diameter is thrice. Here wire number 1 A resistance हो जाएगा rho, resistivity will be the same but wire is same, material is same. So here length, let L upon area of cross section can write here pi r1 is length is same, so L1 L2 both are equal. And resistance of wire number 2, I'm taking here R1, R2. Resistivity is same because material of the wire is same. Length is also same, but radius is thrice. So diameter and radius both are thrice. So 310. R2 will be R1. So R2 upon R1, 2 अल्फा ये कैंसिल हो जाएगा. 9R1 स्क्वायर अपॉन R1 स्क्वायर. सब कुछ कैंसिल होने के बाद हमको मिल रहा है 1/9. R2 will be 1/9 to R1. R2 हो जाएगा 9 ohm. Son, this question 10 volt is more than this 5, so current will be in clockwise direction I. So we can find here I. Total voltage 10 minus 5, 30 opposite here, and total resistance here is 2 plus 1 plus 7, that is also n. 5/10 means 0.5 ampere, and direction of current will be A to B. Direction of current will be from A to B. A to numerical value है 5. So here option 4 is in this question. A uniform wire of carry diameter D. Diameter D. Radius will be R. Carries a current here I1 100 milliampere, and drift velocity here V in wire number 1. In wire number 2, diameter will be half. Here D1 is D, but D2 is half by 2. Same material, so resistive, everything same. It is carrying the current 100 milliampere. We have to find out the drift velocity in second wire. So we know the formula of I is equal to NAEVD. So VD can be written as drift velocity current I upon NA. Here N and E are same because material is same and charge of electron. Number density, material same, so number density of free electrons is also. So we can write here drift velocity is inversely proportional to I upon A. A means can be written as area pi d, diameter 1 4, so pi by 4. You can say finally it is inversely add I upon d square. So Vd for 2, Vd for 1 directly proportional I2. So we can write here I2 upon I1 इनवर्सली प्रोपोर्शनल टू डायमीटर है, तो उल्टा हो जाएगा d1/d2 स्क्वायर. I2 है 200 मिली एम्पियर, 100 मिली एम्पियर, डायमीटर d1 is d, it by also cancel out, and 2 हो गया. ऊपर जाके 2 का स्क्वायर हो गया 4, तो आ गया 8. So VD2 will be 8 times of VD1, that is V, 8V. Here option is 2. Copper wire of radius 1 millimeter. It contains number of electrons per 22 electron per unit volume, and drift velocity we have to find for a current of 10 ampere. So we know the formula of drift velocity, I upon N A. Current is 10 here and 10 to 22. My system area pi R1. मिलीमीटर हमने मीटर में चेंज कर लिया, फिर हो जाएगा ये. And we know charge on electron is 1.6 into 10 to minus 19. So drift velocity after solving coming much meter second. Here option, this question, length of this copper wire is 10 meter and radius here is 10 to the minus 2 upon and pi. Here electrical resistance is 10 ohm. We have to find the current density. Current density. And electrical field is given here 10 volt per meter. Formula between a relation between J current density is sigma 1 upon rho. Rho का फॉर्मूला हो जाएगा आर ए एल. जब फॉर्मूला रजिस्टर कर देंगे यहाँ पे, इट विल बिकम 1 upon r pi r square. एल ऊपर चला जाएगा and hello, we put the values L, length, diameter. Electrical field is also 10 volt per meter. Resistance is also 10 pi. R का स्क्वायर करेंगे, जगह 10 को 4 अपॉन पाई हट गया, ये यहाँ पे आ गया पाई कैंसिल, कैन आल्सो कैंसिल, -4 ऊपर जाकर 10 पर 4 and 10, so 10 पर 5 ampere per meter square. Here option 4. Here on the basis of electrical conductivity, when having smallest resistivity in maximum conductivity, so here the best material silver. So maximum here, maximum conductivity and minimum resistivity, answer here is silver. Option maximum here, conductivity, reciprocal is resistivity, so minimum resistivity. In this question, resistance of platinum wire at 0 degree Celsius, 2 ohm, at T temperature 6.8 ohms at 80 degrees Celsius. This is at 0 degrees Celsius. Temperature coefficient we have to find. Here we know the formula RT is equal to R naught 1 plus alpha delta T. RT is 6.8 R naught H2 1 plus alpha, we have to find temperature difference 80 final minus initial 0 degree Celsius. So डिवाइड करके हो जाएगा 3.4 1 प्लस अल्फा इंटू टी, हम लिखेंगे 80 अल्फा उधर गया 3.4 minus 1 यानी 2.4, so alpha will become 2.4 divided by 80, 8 is 0.3, will become 0.03 per degree. So here option 1 is correct. Can be written also like this, 3 into 10 to the minus 2 per degree Celsius. And 1 is correct. This question we know for metal conductor, we increase the temperature, resistance and resistivity increases, and the reciprocal is here conductance and conductivity. Conductance and conductivity conductivity. And for semiconductor, if we increase the temperature, resistance and resistivity decreases, and conductance conductivity. We are talking about the resistance. So for conductor metal it increases, semiconductor decreases. So option 3. In this question, two resistances 100 ohm and 200 ohms, they are connected in parallel. Connected in parallel. The ratio of thermal energy by developing in 100 ohm, that means ratio thermal energy, एनर्जी का रेशियो निकालना है in 1 and resistance in 2. तो हम एनर्जी लिख सकते हैं पावर, मीन सपोज दोनों का हमने सेम वोल्टेज दे दिया P, पैरेलल में वोल्टेज सेम होता है, तो एनर्जी का फॉर्मूला होगा V² अपॉन R 1 इंटू टाइम T, टाइम सेम है, R2 इंटू T, एंड V² T कैंसिल हो गया, उल्टा हो जाएगा R2 अपॉन R1. R2 means 200 upon R1 means 100. It is 2. Energy ratio will be 2 or 2 by 1. So option here is